Okay, I'm going to get started. I hope I won't be too distracted by the chat
Chat.
here. What I'm going to suggest everyone do right off the start, which I think everyone has, is to turn off your microphones and turn off your cameras. It saves on bandwidth. And essentially, I don't need to hear what you guys are going to say. I'm going to ask for some answers sometimes. The best way to respond to me is put it in the chat. If there's a concept that you don't understand, or I'm going way too fast or way too slow, this is where you're going to write to me. I will try to follow along as we go through this. I do want to sort of speed through this because I know an hour evaporates so quickly. This time is just so precious. I want to get through as much material as possible. Welcome everyone. My name is Tim Chapman. I'm going to be leading you guys through the next 3 sessions. There's 3 one-hour sessions. It's this Monday, next Monday, and the following Tuesday, and it's not a Monday because that Monday is a holiday. Thank you for reminding me of that, whoever sent me that reminder. Essentially what we're going to do is we're covering the bare bones of grade 9, the bare bones sort of essentially the essentials of what you're going to need for next year. Certainly you're not going to be as strong as if you'd gone through the whole thing, all the courses, done all the exercises, etc., etc. But that's totally fine. I just want to get the essentials in there so that next year you're not scratching your head going, oh my God, I am so lost. Why didn't I do any math last year? So that's why we're here. Today, what we're going to do is we're going to go through some stuff that's probably a lot of review, but it's also really good to cover over. And then the next 2 sessions are going to be totally, they're going to be lots of new stuff, and it's going to come at a really fast rate. I intend to record these sessions, and I do want to show you here at the bottom, if you log into your Canvas and you go to your Math9 course, and at the very bottom, if you click on modules here, let me just go into the student view. I'm going to do this very quickly. So if you go into your Math9 and you go all the way to the very bottom, and this can be in your sections, you won't see me as your teacher, you'll have your regular teacher here to mark you. And at the very bottom, I'm hoping that what you're going to see is a Control-Alt-Math module. There's an introduction letter, that's the one that I sent originally. I really want to talk about calculators very quickly here in a minute, but essentially you'll go into the blank notes and the quizzes. And this is what I'm guessing a lot of you have done is you've clicked on either the picture or these links, and it will bring up the PDF, and this is what you can print off. This is what we're going to be filling in as we go through the lessons. So you see this, and it's going to match with my screen here. As you go through, you're going to print these 2 things off. So there's going to be a notes, which we're going to go through in class, and then there's going to be a quick quiz just to check your understanding. I want you to know that when you're doing this quiz, I want you to use your calculators. I want you to use your notes. I want you to use whatever you can to figure out these questions. My purpose right here is for understanding. It isn't to grill you and test you and trick you. A lot of the questions that are in the quiz will be ones that are very similar to what are being in the notes. When you finish that, you're going to submit your session 1 quiz here. Again, I'm not going to take very much time to go through this. This is perfect. When you've done, you can scan it with a scanner and a printer, or you can simply take a picture with your phone. You're going to take 2 pictures, and when you click on the start assignment, you're going to upload your 2 files, your 2 JPEGs, or your 1
Yes,
PDF,
Mom.
and you're going to finish that. The next page I will do after. I'm sorry, I'm just going to leave here. The next page I'm going to do after I finish this, I'm going to upload my video of the, on YouTube, so you can watch this lesson again and again, put you to sleep at night. So it'll be here, and there will be also an answer key for the notes, not for the quiz. The quiz is more like, I just want to check your understanding. So again, I have to let some people in. So welcome again for everyone who's just joining us. Let me talk really quickly about calculators. So I recommend using a calculator. I recommend really getting to learn how to use your calculator. If you don't have a good calculator, I want to show you a little bit about what, this is my little pitch. It'll be about 2 minutes, and then we'll get going here. So I think calculators are really useful. I would never use a word processor and type out an essay without using a spell checker. I would never do math without having a calculator next to me. It doesn't mean that I'm going to rely on the calculator to do all the work. I have to do all the thinking and the work. The calculator is there just to crunch some numbers. I know how to do it. but often the calculator is just an extra way to double check to make sure that I'm doing it right. If you do go and buy a calculator, this is a great time to buy a calculator because they cost about 10 or 20 bucks for a pretty good one. The things that you want a negative and positive button on it. You want a squared or a square root button. And to have one of these X to the Y buttons is really helpful. And we will see that probably next session. This is a really nice one to have. This is X to the power of Y. If you have a cube root and a cube root and a cube, those are also really handy, but not necessary right away. Again, welcome everyone who's joining us. Number 4 is my favorite button of the whole calculator, honest to goodness, and this year and next year will make such a difference. And it's a fraction button. And this deals with fractions. It helps you simplify fractions. It'll let you add and subtract them. Now, I want you to know how to do this without a calculator, but this is an amazing button. And I'll talk more about this at some other time when I'm not actually during the lesson, but I want to show you how to use this fraction button. And all these other buttons, they're important. But essentially like the sine, cosine, and tangent buttons, you'll need those all for grade 10 and certainly for grade 11 if you continue on to grade 11. And also, you know, there's a few other things. We're not worrying about that. Now, for those of you who don't have a calculator and just have your phones as a calculator, I'm not a great fan of the calculator on the phones. There are some apps that I would suggest you get instead. And one of them is Fraction Calculator Plus for free. And this is something that you can download. All of the apps that I have are free. And this will allow you to do, you know, you click on 5/16 plus 1. These are the whole numbers. This is the numerator. This is the denominator. And it gives you your answer and it simplifies it. This is amazing for doing fractions. And fractions are one of these things that is a big stumbling block for a lot of students. The other great thing is you can click on the screen and it'll actually break down how you do the question. So, you know, this is obviously a different question. It's a third plus a fifth, and it shows you how to come up with a common denominator, and it works it through for you. So this is another great way to double check to make sure you're doing it right. The second one that I want to point out is PhotoMath. This is a great one for double checking to see if you've got the right answer, or if you're doing a question and it's like, I am so stumped, I don't know where to approach this from. What you can do is use your phone, you take a picture of the equation, and it shows you a solution with the steps. This is something that you'll probably want to get eventually. And the last one I want to mention is Desmos. It's great for graphing. We're not going to do any of that probably at all in this course, but it's just something that I thought I'd mention. This is all in the Canvas course. All right. I'm going to dump this. Let's get straight to math. So we're going to start on page 1. Again, if you have any questions, you can type them in the chat. I would also recommend everyone mute your microphones and or pause your videos as well. So BEDMAS, we're going to start with BEDMAS. BEDMAS is a really easy way. Let me just get the right color and then we're off to the races here. Excuse the way that I do my notes, but this is an easy way to see. So BEDMAS is brackets. Then we do exponents. Oops. Then we do division. Then we do multiplication. Then addition. And then subtraction, of course. And this is the order that we do these questions in. So we always go BEDMAS. So when we look at this first question here, and I'm going to zoom in here and just make my pen a little. So we have 6 plus 15 divided by 3. So are there any brackets? No, there are no brackets. Are there any exponents? No, but there is a division here, and that's the one. I've lost my color again, so I'm just going to grab that back. So let's do the division first. So 6 stays the same, but 15 divided by 3, that gives us 5. And now we look at this, we're going to start BEDMAS again. No brackets, no exponents, no division, no multiplication. We do have an addition, so it's 11. Awesome. I'm just going to add one more person in here, and we're going to keep going. All right. So in this question, we're going to look at bed mass. And if you want, I often on these ones, I'll even write bed mass just as a reminder. So I don't have to keep in my memory. My memory is empty just so that I can concentrate on the math. So brackets. Oh, hey, here's the brackets right here. So we have to do everything inside the brackets. Inside the brackets, we're going to start bed mass again. So inside these brackets, is there another brackets? No, no exponents, no division, no multiplication, no addition. Oh, subtraction. So let's do that. 4 minus 1 is 3. And now we're going to be left with this one. We're going to start bed mass again. No brackets, no exponents. We do have a division, and it's going to be 3. Okay, we're going to get a little bit more complicated here. So here, these brackets that they use is just to make sure that we know that we're starting with a -4 instead of subtract 4. Sometimes some people will read it and go, well, it's something invisible -4. That doesn't make sense. It's just a -4, and that's why they put it in brackets. So we don't have to worry about that bracket. We can get rid of that. +5, -9. We do have a set of square brackets. We need to deal with that. So we have -1 minus -5. And when you subtract a negative, it's like adding it. And we're going to cover that here in a second, but I'm going to write when subtracting a negative. I'm just going to let someone in here. Same as adding positive. And I could explain that, but I don't really think I have much time to do that. So just know that if you're subtracting a negative, those both turn to a positive. And I've just made a mess of that, so I'm just going to rewrite. Oops, here. So you have -1 plus 5. And I'm just going to keep rewriting this and simplifying it as I rewrite it. So -4 plus 5 minus 9 minus, what is this? -1 plus 5. I have 5 positives. I'm taking 1 away, so it's 4 positives. And I could do that, but so I'm subtracting whatever's in here, and whatever's in here is a 4. Okay, and bed mass, again, we don't have any brackets anymore. We don't have any exponents, no division, no multiplication. We can do addition and then subtraction. So -4 plus 5, I have 1 more positive, so that's going to be +1. Just going to put a little plus there. -9, -4, -6. 1 minus 9 is -8. -8 minus 4, -8. And then I'm going to take 4 away, so that's -12. Another 6 in the negative direction is -18. And I believe that's my answer. And I'll check those afterwards. So that's a bit more complicated. And again, if you know that you have troubles with the negatives and just have to get that really straight in your head, then use a calculator. So at this point, you can just type these right into the calculator. -4 plus 5, -9, -4, -6, and it gives you it. If you have a problem remembering the negative, subtracting a negative, then do this in your calculator is -1 minus -5. And it's going to be like 4. Oh, okay. That's fine. And you just have to trust that it's right. All right, let's keep going here. Here's a good bed mass. I'm going to write bed mass again in the bracket, in the corner here. All right. So in here we have a set of brackets. So let's do the set of brackets first. So I'm going to rewrite this as 3 times 4 divided by 2 over 3 minus, and what's in the brackets? 2 plus 3, which is 5. Okay. So we've done the brackets. Any more brackets? Nope. We're going to start again. No exponents. Well, we do have a division, and that's this one. So let's rewrite that as 3 times 4 divided by 2 is just 2. 3 minus 5. So again, we're just taking one step at a time. I don't mind writing. Pretty fast to write. Okay, no brackets, no exponents, no divisions anymore. We do have a multiplication, which is on the top. So let's do that. 3 times 2 is 6. we have 3 minus 5. With these, I do know that the fraction button is a big division, but we're not going to worry about that yet because we can think of this as like all of this divided by all of that. So essentially, we're going to do the top, and we're going to do the bottom, and then we'll do the fraction. So this is going to be 6, and 3 minus 5 is going to be negative 2. And now we can do this. 6 divided by minus 2 gives us negative 3. All right. This is a slightly different one, and you'll see this more and more as we get through math. They give you an equation with a bunch of letters, and they say, well, what if x is 6 and y is minus 2? Well, it's no problem. What we do is whenever we see an x, we're going to replace it with 6. And wherever we see a y, we're going to replace it with negative 2. I'm going to see if I can do that with fancy colors in a second. So I have minus 5 times, instead of an x, we're going to put in a 6. Minus 2 times y, but instead of y, I'm going to use negative 2. And that's going to be 4 minus, and in brackets, x, which is going to be 6, divided by y, which is going to be negative 2. And I can put that in brackets just so we know it's a negative. But that's fine. If we don't do that as well, I know it's 6 divided by negative 2. It's not 6 divided by minus, or subtract 2. Anyways, I hope that makes sense. So let's do this. Let's do the brackets first. Again, I've just left these in brackets just to show you that these are the numbers. So we don't have to worry about these brackets. I'm just going to remove them. This is like 5 times 6, so this is 2 times. And here's the brackets that I really want to get to. 6 divided by minus 2. So 6 divided by 2 is 3, but it's a negative. And remember, when we have a subtracting and negative, it's like adding. So I'm going to write all over the answer here. I'm just going to jump up to here for a second because I want more space. Let's do it in order here. Bed mass. So there's no more brackets. There's no exponents. Let's do the division. No more division. Let's do the multiplications. So we'll do this one. We'll do this one. So negative 5 times 6 is negative times positive is negative, and I can cover this over in a minute. Here's my negative 30. Minus 2 times minus 2 is positive 4. And then we can also write this one. I'm just going to do this because I can skip ahead here one step. We've done the division. There's no more multiplication. I'm doing the addition. I'm going to do the subtraction as well, but this is going to be like 4 plus 3. Okay, and then let's do the last one. Negative 30 plus 4. So we start way back in the negatives, and we're going to go in the positive direction 4. So we're going to get less negative, which is minus 26. And 4 plus 3 is 7. And it's a really weird fraction. It is just to show you that we can still do it. All right, I'm going to just take a 30-second breather, guys. If you have any comments, am I going too fast? Am I going too slow? You have any questions? If you have specific questions about like, hey, can you do C again? Because I didn't quite understand that. You can hang on to that. At the end of the session, what I'm going to do is I'm going to, at the end of this, I'm going to say, okay, I'm happy to go through any questions again with you, and we'll just go over them again. I know that I'm going very quickly. I just want to make sure that I cover all the material. And so maybe what I'm going to do is I'll slow down from here on a little bit because we are into this. So that's great. Thank you very much for that. We're just going to switch gears, and we're going to do some fractions. More fractions. And then we're going to get into those sort of questions again a little bit. And I will definitely go nice and slowly. Oops, that's that. Perfect. Okay, so there's going to be 3 different types of fractions that we're interested in. Proper fractions. That's where the number on the top is smaller than the number on the bottom. I like to think of these as like triangles. The number on the top is littler than the number on the bottom. Oops. It can be 1 out of 25, smaller on the top than the bottom. It can be 98 over 99, whatever you want. Those are what's a proper fraction. An improper fraction is the opposite. It's where the number on the top is way bigger, or at least bigger than the number on the bottom. These are like top-heavy ones. Way bigger on the top than it is on the bottom. Those are improper fractions. So you can have 3 over 2. You can have 15 over 8. You can have whatever you want, as long as if the improper means it's bigger on the top than on the bottom. And a mixed number, it's one where there's a whole number and then a fraction. They tend to be mixed number plus a proper fraction. You wouldn't typically have 2 and 3 halves. You won't see that because that's not simplified. You'd be able to take 2 halves out of that, and that would be 3 and 1/2. But a mixed number is one that has a whole number added to the fraction. Okay, so again, 2/9 is that a proper fraction, an improper fraction, or a mixed number? Well, of course, this number here is smaller than the one on the bottom, so it's going to be a proper. This one, it's got a whole number, so it's mixed. And the third one, we've got 12 over 7. It's like a top-heavy fraction. It's hot. Maybe it's like driving along and I've got a Volkswagen van, and all my weight is at the top and nothing at the bottom. Sorry, that's just my bad drawing. 12 is bigger than the bottom, so it's going to be an improper. Now, we need to know those because the next question is going to start asking a question. It's like, write each as an improper fraction or proper fraction in the lowest form. So this is an improper because it's top heavy, and what they want is to write it as a, I'm guessing as a mixed. This is a really weird one. Or mixed. We'll write this mixed. So I want to show you a few ways to do this. I'm going to write it here. 12 over 9. So how I get this into a mixed number is I say, how many 9s could I get out of 12? Well, I could get 1 9. If I had 2 9s, that would be 18, and that's too much. I don't have 18 to give up. So 1 9, or if you say 9 times 1, be 9 ninths. If I took 9 ninths out of there, how many ninths would I still have left? 10, 11, 12, or 3 of them. So essentially what we're doing is, this is like a long division question, to be honest. It's how many 9s can you get out of 12? Or you could say, oops, yeah, that's right. So you get 1 9, giving you 3 left, and it's a remainder 3. But instead of the remainder 3, that's what you're going to put here. And essentially 9 over 9 is 1. So 1 remainder 3 out of 9. Typically, they're not crazy hard ones. Essentially, what you're doing is saying, how many ninths could I get out of 12? Well, I can get 1. And 9 ninths, I would have 3 ninths left over. And so the mixed number would be 1 and 3 ninths. Now, we are sort of done, but we can simplify this. And what I want to show you is the simplifying. And this is, again, why calculators are so fantastic. It will simplify it for you. But essentially, what we do is when we're simplifying, we're looking at the fraction like 3 ninths. We're saying, is there a number that we can divide both top and bottom by to give us whole numbers on both top and bottom? And if we divide by 2, this wouldn't give us a whole number. But if we divide it by 3 on the top and on the bottom, it would give us 3 divided by 3 is 1, and 9 divided by 3 is 3. So 1 and 3/9 is the same as 1 and 1/3, and that is the simplified version. We're going to do a bunch of the simplifying because some teachers definitely in the future will want you to simplify. Almost every question actually in math says, and simplify. It's just to show that you know how to do this trick too. We'll practice some more here in a minute as they come up. Instead of doing a lesson, I just want to do the work with you, work through these questions. And as we go through them, I'm going to be showing you different things. And hopefully they'll sink in by the end here. Oops. So 12/9 is equal to 9/9 plus another 3/9. 9/9 is 1 and 3/9. But I want to simplify, so I'm just doing this again. I know that I can divide top and bottom by 3 to give me whole numbers in the top and the bottom. So I'm going to do that, which then makes it 1/3. The other thing that you can do, and it's a bit speedier of a way, is you can say, can I divide the top and the bottom by any number? Yeah, if I divide this by 3, it gives me 1. If I divide this by 3, it gives me 3. And this is what we're eventually going to work towards. But just know that when I took my 1 and 3/9 and divided by 3 and divide by 3, it gives me 3 divided by 3 is 1, and 9 divided by 3 is 1/3. This is just the faster way to do this, and we're going to start doing this a lot more, especially next week. We're going to start doing this a lot more. Don't despair, it'll come. All right. I'm going to take the 5 and 2/6 and make it into an improper fraction. So let me do that up here where I have a bit more space. 5 and 2/6. 5 and 2/6. Now I'm going to show you the coolest way to do this. I draw an arrow around. I do that. And I'll show you what it means. And I'll do a times and a plus. So this is going to be like your visual reminder. Essentially, we're going to take the bottom of the fraction, the denominator, and multiply it by the whole number. So 6 times 5, which is 30, and we're going to add the top of the numerator, plus 2. And then on the bottom of the fraction, we're going to use the same as what's on the denominator. So 6 times 5, and we follow this arrow. This is why I draw this nice little arrow here. 6 times 5 is 30, plus 2 is 32, and the 6 gets dragged right over. I'm going to do a couple more examples just because it's just good practice. So I'm going to do 7 and 2/5, why not 3 and 4/6. So here I would draw my little arrow, my little curved arrow. I know this is the times and this is the plus. So 5 times 7 is 35, plus 2 is 35, 36, 37. So 37 goes on the top, and this comes on the bottom. So 35, or is 37 over 5. And this is sort of the opposite. What I'm doing is the opposite. If I wanted to go back to this form from here, I'd say, how many 5s can I get out of 37? Well, I could get 7. 7 times 5 is 35. So I'd say 35/5 plus another 2/5. And 35 divided by 5 is 7 and 2/5. So I've sort of gone from mixed to improper and back to mixed. We don't normally have to do that. I just wanted to show you that sort of these are the opposites of each other. So again, if we wanted to convert this mixed to an improper where it's going to be top heavy, we're going to take the 6 times 3, which is 18. And we're going to add 4 more. 18, 19, 20, 21, 22 over 6. Now, this is where the simplifying is going to get trickier. So you can say, okay, well, you got to simplify that. Can you divide the top and the bottom by something? I know I can because they're both even, so I could divide by a 2, at least. And it might be more, I don't know. 22 divided by 2 is 11, and 6 divided by 2 is 3. And that fantastic calculator button would be able to do this for you. Okay, let's go back to these ones here. So I think we know how to do all these. So 1 1/3. Okay, so I'm going to draw my fancy curved arrow. I'm going to have a times and I have a plus. So it's going to be 6 times 5 plus 2 over 6. Or if you want to do it in your head, that's fine too. So 6 times 5 plus 2 on the top, and the bottom becomes over 6. So this is going to be 30, 31, 32 over 6. And I could simplify this because it does say in the lowest form. So it says simplify. And I think that 2 is the only thing I could divide both the top and bottom by. So I'm going to have 16 over 3. I hope this isn't too crazy for everyone. And again, I'm going to be here at the end of this session to help anyone out with any of these questions. I want to make sure that you understand how to do these. That's my point, the whole point in doing this. Okay, I'm going to give you just 10 seconds. I just got to do one quick thing here. Oh, thank you. It didn't come up in that. Great. All right, so here we go. 3 times 6 plus 2. Or I'm going to just write it here. 3 times 6 plus 2, all over the same denominator, the same bottom number. So this could be 18 plus 2 is 20 over 3. And that's a done deal. Fantastic. Oops, my pen is really wonking out here. Wow. Okay, I don't know what's going on with my pen. Now you have to see me right with my mouse. Okay, let's do this one here. So how many 12s can I get at 90? Well, 10 12s would be 120, so that's too much. I'm guessing 9 would be too much. How about 8? That would be 80 plus 16, no. So what about 7? 7 by 12 is going to be 70 plus 14, which is 84. All right, so I can do that. Also in your calculator, oh, come on. Not sure what is going on with my pen. It's weird. Excuse me, I'm having technical problems here. All right, I'll write really carefully here. So I know that 7 12s is 84. So I want to take 84 12ths out of this. How many are left over? 90 minus 84 is really 6 12ths left over. I know this, 84 divided by 12 is going to give me 7 and 6 12ths. And I could divide both the top and the bottom by 2 or 3 or 6. Let's just go fast. 6 divided by 6 is 1 and 12 divided by 6 is 2. And so my answer is 7.5. Okay. I'm going to keep going, you guys, because we're 35 minutes in. And there's a few things that I definitely want to cover over. The next one being probably the hardest, it takes the longest to figure out. It's something that you guys probably love to hate. It's how to add or subtract fractions. So the first thing that I would look at when I do these, this one will be no problem. This one has mixed numbers. I don't want mixed numbers. I just want a proper or an improper fraction. I don't want any numbers that would just confuse the whole situation. So I'm going to switch this. I'm going to also switch this one, and I'll show you what to do with the whole numbers if there's no fraction involved. I'm going to do this one down here because there's going to be some steps. So step 1 is find LCM, the lowest common multiple. And the way that I do this is I look at the numbers and I say, okay, what numbers could have the common multiple? So a common multiple here if I'm doing 2 and I'm doing 7, so I'm going to list it. What's 2 times 1? 2 times 2, 2 times 3. And here, I'll just write this in here. 2 times 2, 2 times 3. Sorry, that's not. 2 times 1, 2 times 2, 2 times 3, 2 times 4. And I'm just going to list them out for a while. 10, 12, 14, 16, and it just goes on forever. And with the 7, I'm going to do the same thing. What's 7 times 1? 7. 7 times 2 is 14. 7 times 3 is 21 and 28 and 35, and it goes on for a bunch. Now what I'm going to do is I'm going to look at this list and I'm going to find out what's the lowest number that's common to both of those. These are multiples, right? Is 2 times 1, 2 times 2, 7 times 1, 7 times 2. I know that 7 is in this list. It's not in this one, but 14 definitely is, and 14 definitely is. So my lowest common multiple will be 14 for that. Is 14. That's the first step. The second step you're going to do is you're going to multiply top and bottom so that the bottom equals the LCM. So I want to take this 1/2 here. I'm going to multiply the top and the bottom by numbers so that the bottom number equals 14. Well, I know I'd have to multiply 2 times 7 to give me 14, and I have to multiply the top by the exact same number. Okay, hold that thought because we're going to come to step 3 when that's all set, but we're mostly there. Let's do the second one here. This is 10 over 7. What do I have to multiply the bottom by to get my LCM? Well, I'd have to multiply it by 2. If I do it to the bottom, I definitely have to do it to the top. You know, we're totally fair here. Cool, now we're like 85% there. So 1 times 7 is 7, 2 times 7 is 14. This, by the way, the half and the 7/14 is equivalent. If you think of it, you can have half an apple or you can have 7/14 of an apple. It's the same amount of apple, it's just cut a bit differently, and that's fine. What about this one? 10 times 2 gives us 20 on the top, and 7 times 2 gives us 14 on the bottom. And I'm just going to write up to here, step 3, once bottom is the same, add the top, keep the bottom same. We went to all the effort to make them the same. So we can't, you know what, if you imagine is like, actually I'm not even going to do that. Let's just assume that if the bottom is the same and we've got 14ths and we got 14ths, then we can add the tops. So we got 7 plus 20, which is 27, and 14ths stays the same. Can we divide the top and the bottom by anything? I think this is, can't by 2, you can do 3, but this is no 3. You can do by 9, and so no, this is it. 27 over 14, and that is our answer. And it's simplified and everything. Subtraction works exactly the same. It's just instead of adding, you'll subtract. But the first step is, let's switch this into an improper fraction. We got 3 times 4, 3 times 4 plus 4 over 3. So I'm just going to rewrite this here, because that's going to be 12, 13, 14, 15, 16 thirds minus 5 sixths. So step 1, remember, find the LCM, and we can just do this by multiplying. We've got thirds and sixths, so let's do 3 times 1, 3 times 2, 3 times 3, 3 times 4, and it goes on. And with 6, we've got 6 and 12 and 18. We don't have to go anymore because we know that the lowest one is 6 in common. So we want to multiply each of these fractions so that the bottom numbers are sixths. Well, this one's already done, but we need to do this one. So I'm going to just do this in another step here. What do I have to multiply the bottom by to make it a 6? Well, if I multiply it by 2, 3 times 2 is 6. If I multiply the bottom by 2, I have to multiply the top by 2. We total equality here. And then the 5, 6, it's already in sixths, so I can just leave it like it is. Okay, so let's do this math. 16 times 2, it's 32. Sixths minus 5 sixths. Now we're at the final stretch here. Once the bottom's the same, we're going to subtract the top and keep the bottom the same. 32 minus 5 is 27, I hope. And the bottom stays the same. I am absolutely thrilled and happy to do more of these later. And I know I'm going fast. I apologize. We just have tons to cover, that's all. Okay, let's switch this one because I do want to keep zooming through here. We got about 20 minutes left. It's going to be 1 plus 8 times 2 plus 5, right? This is the times and this is the plus over 8. I hope we're doing enough of these that they're slowly making sense again. So this is going to be 1 plus, we have 8 times 2, which is 16. Actually, there's a way easier way of doing this, but I'm going to show you the hard way. 8 times 2 is 16 plus 5 is 21 over 8. I hope that's right. 16, 21 over 8, yeah. And this one I can write as 1, or I can write it as 8 over 8. Because that's one whole one too. It's just cut into 8 pieces, you still get the whole pizza, right? Now that my bottoms are the same, and you have 29 over 8. Now, I don't know whether the answer said to keep it, leave answers as mixed numbers. Oh, okay, so we have to switch back. I'm doing this wrong. We can almost get, well, let's finish this one first. So this is the answer in improper fractions. If you want a mixed number, I have to say, how many 8s can I get out of 29? Well, I could get 24, or 3 groups of 8. 3. And I would still have 5 8s left, which is 3 and 5 8s. This is sort of the thing we worked on a little while ago. Again, how many groups of 6 can I get out of 27? Well, 4 times 6 is 24, so I would 24 over 6. I still have, instead of 27, I have 24 plus 25, 26, 27 is 3 sixths. So I would have 4 and 3 sixths, or 4 1/2. The same with this one. How many groups of 14 can I get out of 27? Well, 2 groups is 28, which is 1 too many, so let's just do 1. So we would do 14 out of 14 minus, or plus 13 out of 14. Sorry, there was my mistake. Is 1 and 13/14. Again, I realize I'm going way too fast on this. Hopefully it'll sort of make sense. We followed the same rules we were just doing earlier. I'm just going really fast because we just have to speed through this. Again, I'm happy to go over this later on. So that's a really small little picture of what you can do when you're adding or subtracting fractions. Just remember the rules. Switch them all to imperfect or perfect square fractions. Find your LCM, multiply the top and the bottom. I should underline the and, so that the bottom is the same as the LCM. And then what you can do is just add the tops and keep the bottom the same. So again, when you're doing your quiz, make sure to have these notes ready and available whenever you want. Now, multiplying is so much easier. It really is. I'm going to write this. I always start with the hardest one, right? 2 is the same as 2 divided by 1. So I'm going to write this as a fraction times a fraction. It's way easier for me to understand that. Fractions are great when you're multiplying them because you're going to multiply the tops, put it on the top. And the bottoms, you're going to multiply the bottoms, 1 times 8, and put it on the bottom. So it's going to be 14 over 8. And it says leave them as improper, which is perfect. It's done. It says I do have to simplify it. So again, this is half the trick. This is the correct answer, but they want this simplified. So is there anything we can divide the top and the bottom by and come up with a whole number? I'm going to try 2, because I don't think 4 goes into this and 8 doesn't go into this. So I think this is it. 14 divided by 2 is 7, and 8 divided by 2 is 4. 7 over 4, perfect. Let's do this one. Again, let's switch so that it's an imperfect. So it's going to be 8 times 4. I'll just write it out because it's easier. If you can do this in your head, then fantastic, all the better to you. You'll just get faster at these. I also want to show you a trick because I think that these will actually work really well with this trick. And this is where they're going to differ from last year's math. 8 times 4 is 32, plus 3 is 35, over 8 times 8 over 9. Okay. Now, this is going to be an ugly question because I'm going to go 35 times 8. It's going to give me some terrible number that I can't do in my head. And 8 times 9 is over 72. Again, awful math because the numbers are bigger and I just don't know how to deal with them. But this is a beautiful thing about this, and I will actually celebrate by switching my colors here for a moment. Let's go for a nice purple. When you have a fraction times a fraction, there's no adding, there's no subtracting, it's just times. What I can do is I can cancel something from the top and the bottom. So I'm going to look for numbers here. The same, it's sort of the opposite. Well, it's the same as this, where I'm dividing by 2 on the top and the bottom. Here, I could divide by 8, which gives me 1, and I could divide this 8 divided by 1. So you have to pick a number on the top and the bottom and divide both of them by the same number. It's the same as I'm doing here. It's just with a pair. And it'll make your life way easier, trust me. And so I've got, I take this 8 and I divide it by 8, it gives me 1. I divide this 8 by 8, it gives me a 1. I don't think I can divide the 35 and the 9 by anything and leave me with the whole numbers. So I'm just going to be stuck with that, which is totally fine. But my answer is going to be 35 times 1 over 1 times 9, 1 times 9, or 35 over 9. Way easier than like a 400 over 79 or something like that, or 72. Okay, we'll keep practicing those because I think that these will come up more and more here, even though we've only got one more. All right. First thing is, let's switch these both to improper. So here, it's 7 times 4 plus 5 over 7. So 7 times 4 plus 5 over 7 times 4 times 2 plus 1. 4 times 2 plus 1 over 4. So again, times and plus, times and plus. Okay, so let's do that. 28 and 5 is 33 over 7 times 4 times 2 is 8 plus 1 is 9 over 4. Now, is there anything I can divide top and bottom by? Actually, there isn't. This I can't divide by. This is a 3 and this is a 3, a 6. I can't do any of those. So it's going to be a really odd number. I don't know what that is actually. I'm going to grab my calculator. 33 times 9 is 297. 297 over 28. It's an awful looking fraction, but apparently there it is. I can make that mark out of 3 because that's a harder one. Okay. And lastly, we've done the addition and subtraction. We've done fractions where we're adding them. We've done them where we're subtracting them. We've done them with the multiplication. We just have to do the division now. And the division are like one step slightly more complicated than these, but really not much more complicated. First thing we're going to do, let's switch it into improper and improper. Sorry, that was a really weird curve. Okay, so this is going to be 6 times 3 plus 5 over 6. 6 times 3 plus 5 on the top, and then 6 stays at the bottom. We're going to put the divided with sign in there, and 3 times 3 plus 1 over 3. So 3 times 3 plus 1 over 3. Okay, so let's do it. 6 times 3 is 18. 23 over 6 divided by 3 times 3 is 9 plus 1 is 10 over 3. Okay, so we're ready to go. This is our normal division question. And what we're going to do is we're going to keep this, the step 1 is to keep this first one the same. 23 over 6. The second step, I'm going to do this in the other color again because I really want to make sure this is clear. We're going to change that to a times. So we're going to flip the sign. Instead of doing the dividing, we're doing the opposite of dividing, which is multiplication. And then the last thing we want to do, I want to get another color here for this, is we're going to flip this fraction. So top to bottom, bottom to top. So instead of the 3 on the bottom, it's going to be now on the top, and the top now is the bottom. That's what's involved with doing a division. So again, keep the first fraction the same, flip the sign from a division to a multiplication, but you also have to flip the fraction from top to bottom, bottom to top. That's the trick with these. Now we could do 23 times 3 and 6 times 10, or we could say, are there any numbers that we could divide top and bottom by? Yeah, we could divide this by 3 and this by 3. 6 divided by 3 is 2, and 3 divided by 3 is 1. And that's, I think, as far as we can go. This just helps you so that you don't have to simplify so much. You could also go just directly the opposite here. So 23 times 3 would be 69 over 60. And your calculator fraction button would simplify this, but I could also divide by 3, divide by 3. And this gives me 23 again. And this gives me 20. Same answer. It's just with this one you can cancel, and it's much faster. And you'll find out next week this is the way to do it, is to learn how to just, okay, divide by 3, divide by 3, and then you multiply it through. It's so much simpler and cleaner. Both ways work. Ah, there you go, reciprocal and refliprocal. That's an awesome way of remembering it. Oh my gosh, I'm gonna have to use that. Thank you very much for that. Okay, here we go, the last one. Let's make this an improper just so that we keep everything legit here. Divided by, and this is going to be 2 times 2 plus 1 over the 2 at the bottom. So we have 11 tenths divided by 2 times 2 is 4 plus 1 is 5 over 2. Okay, so step 1, keep the first fraction the same. So this is 11 over 10. Step 2, let's flip the divide. And when we're going to switch the divide into a times, that means we got to flip this second fraction top to bottom, bottom to top. Okay, I'm going to show you the old way, and then I'm going to show you the faster way. For sure it works is 11 times 2 is 22, and the bottom 10 times 5 is 50. We would divide both top and bottom by 2 to simplify, I think. 11 over 25. And that is our answer. The other way that we could do it, I like this purple. So we can say, are there any numbers that we, top and bottom? It can't be bottom and bottom. I know I'm tempted to just cancel those out, but it has to be one on the top and one on the bottom. Doesn't matter if it's these top and bottom, these ones. Doesn't matter. It just has to be top and bottom. If you're going to divide the top, one of the numbers by 2 on the top, you have to divide one of the numbers on the bottom by 2. And 11 times 1 gives you 11. 5 times 5 gives you 25. You just sort of skip this step by doing a little bit of canceling. All right. We are very quickly running out of time, so I'm just going to, oh, we are pretty much out of time. I'm just going to quickly look and see which ones would be the best ones to hit. So we've covered these. Essentially what I wanted to worry about was if you have subtracting and negative, it's like adding a positive. We're subtracting a negative, so it's -6 plus 5 plus 2. And the way that I figured these out is when I have negatives and positives, or positives and negatives, I'm thinking about a number line. If this is my 0, 1, 2, 3, 4, 5, 6, I have -6. Am I going to go into the positive direction, or am I going to go to the negative direction? Well, 5 is the positive direction. This is the positive. This is the negative direction. So I'm going to jump 5. So it's -1 plus 2. I'm going to pop another 2 in there, and it's going to be 1. Calculators are also great for doing this. Essentially, the reason why I have these here is just to reinforce that when you're subtracting a negative, it's like adding a positive. And these kind of brackets, well, I'll go over that in a second, but these brackets are just to show that it's a -4. It isn't saying something subtract 4. It just, essentially they mean the same, but -3 plus 1. So you have -4 or -4. Take another 3 away, so you're even more negative. -7 plus 1 is -6. This -6 going in the positive direction all the way up to -1, and another 2, so it's going to go into the positive 1. Or 8 minus 4 is 4 plus 3. 4 plus 3 is 7. Same with these ones. That's going to turn into a plus, so we have 4 minus 1. If you're adding a negative, the same thing as subtracting a positive. It doesn't matter. And then plus 8. 4 minus 1 is going to be 3 plus 8 is 11. Sorry guys, I'm zooming through these so quickly, but we just have tons of stuff to get through. And we're getting almost there. These ones aren't so bad. I want to show you guys when you're adding or subtracting, when you're multiplying or dividing negatives, this is it, is if you have a positive times a positive, you get a positive. Positive times a negative gives you negative. Or a negative times a positive, same thing. And a negative times a negative, we've already talked about, is a positive. There's some really great sayings about, a good guy and something good happens to him, that's good. A good guy but something bad happens to him, that's bad. If it's a bad guy and something good happens to him, that's bad. But if it's a bad guy and something bad happens to him, morals put aside, then it's good. Again, I can explain that. It's not very ethical. Here's what I know about when you're multiplying or dividing a decimal. If there's odd negatives, then the answer is negative. If there's even negatives, then the answer is positive. So if there's 0 or 2 or 4 or 6 negatives, multiplied or divided, then it's positive. And if it's a 1 or 3 or a 5 negatives, and you'll see the This one, it only gives you, like, there's 2 negatives in this one, so the answer is going to be positive because it's even number of negatives. There's 1, there's 2, so it's going to be a positive. Or you can think of these as canceling out. This is going to be different, but essentially if we're looking at this, there's a negative and then a negative, so it turns to a positive. And this side, it's negative times a negative, it's going to be a positive number. And then we just multiply the numbers. 3 times 5 is 15, times 1 is 15. And 2 times 3 is 6, times 4 is 24. So it will be 15 plus 24. Here we can do it. 2 times minus 7 is minus 14. Minus 3 times 5 is minus 15, but a negative divided by a negative gives me a positive, so it's going to be 14 over 15. Again, I realize that I'm going just ridiculously fast here, and I will definitely hang in here. I just want to make sure that I've covered the basics. Here I would multiply the tops, so I have 4 times minus 2 gives me minus 8. And on the bottom, 0 plus negative 3 gives me a negative 8. So I'm just adding a negative. It's like 0 minus 3. And now I have a division, negative divided by a negative, so it gives me a positive. I'm just going to zoom through this. These are the same questions that I was doing earlier. It's just a little bit more complicated because there's an extra one. Same as the ones that I've already done, so I'm just going to skip those in the examples. These are very similar. I'll show you a couple of these. So I want to just put this as a fraction so that it makes all the sense to me. I have 1 negative in all of these, which is an odd number of negatives, so my answer is going to be negative. I can even put that right in my answer just so I don't forget it. And essentially with the fractions, I'm multiplying all of them, so I'm just going to multiply the tops. But I'm going to show you what I'm going to do here. 7 times 8 times 12 on the top. And on the bottom, it's 1 times 5 times 7. Okay, so what is 56 times 12? It's a horrendous number. It's going to be awful. But what I can do is, if it's all multiplies and divides, I can cancel something from, I can divide the top and the bottom by the same number. So why don't I divide this by 7 equals 1, and I can divide this by 7, which is equal to 1. And I don't think I can do any more, but that makes it much more reasonable. So I have 8 times 12, which is 96. And on the bottom, I have 1 times 5 times 1, which is 5. And remember, I've got my negative in there because there's my negative. So my answer is negative 96 over 5. I can do another example here just because I think these are really good as practice. So essentially with fractions, I'm multiplying them all. So I'm going to multiply all the numbers on the top and put it on the top and multiply all the numbers on the bottom, which leave me bottom's the number. But I can actually cancel a few of these out. So first thing I look at is the negatives. There's 1 negative in all of these 3. So the answer is definitely going to be negative. I'm just going to put it right in the answer so I don't forget. This is going to be 4 times 1 times, oops, that wasn't a times 8. 4 times 1 times 8. And on the bottom, I have 7 times 8 times 5. All right, let's see if we can divide the top and the bottom by anything in common. Yeah, I can divide this by 8 and this by 8. That makes it way more reasonable. Yeah, I understand that you guys have to go. Let me just finish this problem. I'm going to talk a little bit about what I'm hoping you guys will do for this week. And then you can go. But thank you for hanging in there. I know that I tried to go as fast as I could, and this is as fast as I can go. Now let me just finish up this problem. 4 times 1 times 1 gives me a 4. And 7 times 1 times 5 is a 35. And that's my simplified version. Okay, I'm going to go through this. I also want to go through the square roots, and it's a very, very brief, quick look at this. Let me just quickly go back to this one here. No, that's not it. Where is it? Sorry, guys. So for this week, what I really want you to do is, finish up the notes as much as you feel like you need to. I think that it's really helpful. While you're doing your quiz, I want you to use your notes and use your calculators. I do want you to show all your steps, show your thinking. It really helps me. I'm super generous with part marks, and I'd like to give you the benefit of the doubt. So when doing this, don't give an answer. Show 8 divided by 2, and then it'll give you 4. There, I gave you the first answer. But these look exactly like what we were doing. With these ones, you can do this one first and then add it, or you can make them all the same number, they're all the same lowest common multiple, and just do that. They all look very similar, and there's a couple of square roots. If you miss the square root part, because I'm going to come to it in about 5 minutes, then look back here on the website and look for the Zoom forward ahead, like the 45 or 50 minutes, and then catch up on the last little bit. It's not really that complicated once you follow through with me. So if you have to go, then by all means, you have to go. If you have another 10 minutes, that's all it should take. And if you have longer than that, I'm going to hang out here and help whoever wants help with the notes, or you can even write your quiz right here and there, right here and now. And I'll certainly be able to give you hints. Or like, you can say, how do I start on this one? Oh, well, let's think about this, or let's look at this example, and I'll be able to be here as sort of just to help. All right. Maybe what I'm going to do is, we know how to do these. I'll come back to these in a moment. I just want to look at the square roots. So you know that a number like squared means that we're going to multiply that number twice. So 5 squared means 5 times 5, or 5 multiplied by itself twice, which is 25. A square root is the opposite. So square root of 25 is sort of asking what two exact numbers multiply to make 25. And I could say, oh, well, it's 5 times 5. Now that I have a pair, I'm going to pull that out of the square root, and it just becomes 5. Because we know 5 times 5 is 25. I'm going to do a couple more examples here. Let me do, I'm just going to come here because this will help. Let me just see if that helps. I think it's because I've got the text tool. Okay. So the square root of 36 is asking what two numbers multiply to make, what two exact numbers? I could do 18 and 2, but that doesn't count because they're not exact numbers. So what two numbers multiply to give me 36? Well, I know it's 6 times 6. Now, I'm going to just draw this in here because this is sort of what no one tells you, but essentially when we're talking about a square root, there's a little 2 in there. And that's square root. So it says what two numbers multiply to make 36. If you find a pair, you can pull that pair out of the square root symbol, and it just becomes one of those pairs. And then there's nothing in here, so we can just leave it. I'm going to show you another example here. 64. What is the square root of 64? It's the square root of 64. We don't write the 2 because we just have to sort of assume that it's the square root. Unless we put something different, then it'll mean it's a cube root. But two numbers multiply to be 64. Oh, 8 times 8, I bet. 8 times 8 is 64. So there's what two numbers multiply to make 64? Well, it's 8 times 8. They're identical numbers. Because we've got this pair or the twin here, we're going to be able to pull that out, and it just becomes one of those. Now I want to show you something slightly different. we're just going to go through very quickly again because you should know this, is sometimes when we get a number like 18, what two numbers multiply to make 18? Well, 3 and 3 make 9, 4 and 4 are 16, 5 and 5 are 25. Oh, it's somewhere between 16 and 25, so there is nothing. Sometimes what they do is you can find out an exact answer, like you can say this is 2 times 9 and you make a factor tree. And so the square root of 18 is 2 times 3 times 3. You look for the pairs because this is a square root. You pull that pair out, it just becomes one of those pairs, and you still have the 2 that's stuck in there. It doesn't have a pair. And that's the exact answer. Or typically what I might do is I say, give me to 1 decimal place. You go into your calculator and you do the square root of 18, which gives me like something like 4.24. And there's a third way that we can do this. And sometimes what I will ask is, tell me what to the closest decimal place, tell me what the answer is without using a calculator. And it's like, well, I don't know my 4.2 times tables. Like, how am I supposed to do that, Tim? Like, honestly, there is a way, and it's sort of, once you learn it, then it's no problem. Let me just, I'm gonna get rid of this just so I have a blank canvas again. Square root, oh, okay, of course, I have to do this again. Excuse me, guys. Square root of 18, I think was the number. So we're going to look for perfect squares. Perfect squares are ones that have whole numbers. Like a perfect square is the square root of 25, which is square root of 5 times 5, which is 5. And square root of 16, which is equal to square root of 4 times 4, which is going to be 4. I know 18 is between the square root of 16 and the square root of 25. So what I want to do is I'm going to draw a number line and I'm going to put the perfect squares that are above and below this 18. It doesn't really matter where you put them. I'm going to just put this as 4, which is the square root of 16. And here's 5, which is the square root of 25. This is 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, something like that. So I'm guessing the square root of 18 is right about there. Sometimes this is only like 1 or 2, so it's really easy. Sometimes it's quite long, and you just have to guess. So if this is the square root of 18, if I make this and make this 5, there's 4.5, there's about 4.25 or something like that. Something like that. And so that's what I'm guessing the square root of 18 is. And I think I got when I typed it into the calculator, is 4.2426, blah, 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 blah. So I'm really close. So when we go back to this question, we're going to go to the question number 14. Without using a calculator, determine the square roots of the following irrational numbers, irrational being like it's in a square root form, to 1 decimal place. So the square root of 40. So my first step 1 is find, perfect squares above and below. So what are my perfect squares? I think that square root of 36 is pretty close. Oops, 36 is equal to the square root of 6 times 6. So square root of 36 is 6. That's just below. What about 7 times 7? Square root of 7 times 7 would be square root of 49. Okay, so I'm going to make my number line here. So I think I've got them above and below. 40 fits between 36 and 49, so that's about right. So I'm going to draw my 6 and my 7 in there. That's going to be my square root of 36 and my square root of 49. Oh, I'm guessing 40 is somewhere around here. It's close to the 36. There's 4 here and 9 there. Okay, I'm just going to call it that. Square root of 40. This is sort of where you have to eyeball it. So I guess it's close enough. It's about right around there. Okay, so that's 40. This is 6 and this is 7. This might be 6.3, 6.4. It's hard to tell. I'm going to say 6.3. And as a double check, I'm going to grab my calculator and I'm going to try it out here. Square root of 40 is 6.324. All right, so I got it right. Okay, I'm just going to erase this really quickly just so that I can do this last one. And then I'm going to cover these few at the bottom, which is sort of a little above and beyond here. Square root of 50. So first step is finding the perfect squares. Square root of 49 is 7 times 7, which is equal to 7. And the one that's bigger than that is probably 8 times 8, which is 64. 8 times 8. Find my pair and I pull it out and I just want one of them. So there we go. Square root of 64 is 8. Square root of 49 is 7. This is a great way to use your calculator to double check to make sure you're doing the right thing. All right, so there's 7. There's 8. That'll be square root of 49 and square root of 64. Where does 50 fit in? Oh, it fits in right there. Not nearly. There's 1 here, and there's going to be like 23 there or something like that. No, 13 there. So I would call that maybe 7.1. And again, I'm going to just double check. I'm not using the calculator to determine. I've got an answer. I just want to double check my answer. Square root of 50 is 7.07. Awesome. So 7.1 it is. These ones, again, I just wanted to show you because you'll probably look at these again in grade 10 at some point, but there are tricks to some of these. Square root of 0.0049. So you can do this in your calculator too. And this is a good way of doing it, 0.0049, and you take the square root sign and you get 0.07 or something like that. I'm going to show you another way to do this. I'm going to turn this into a fraction. This is square root of 49 over 1, 2, 3, 4. So 1 with 4 zeros behind it. And then I know that this is a perfect square because it's like 7 times 7. Here, I'll do this over the square root of 10,000. And that's going to be like 7 times 7. And that's going to be like 100 times 100. 7 over 100, which is 0.07. So you can do it without a calculator, but if you're allowed to use calculators permitted, absolutely use it. Same with this one. This is a bit more tangible. I'm going to do this on the other side because I think I've got room. This is a 0.81, the same thing as 81 over 100. You could do the square root of 81 over the square root of 100. You'll learn that law sometime next year. Square root of 81 is 9, and square root of 100 is 10. This gives me 9/10 or 0.9. This one I'm just going to divide 3 and 48. This one you could say this is going to be 8 minus 11 minus 3. That's an easy one. The same thing as 1 over 16. Square root of 1 over square root of 16. And the square root of 1 is 1 times 1. Square root of 16 is square root of 4 times 4, which is just 4, or 0.25. Now, I went through that just ridiculously fast. So again, apologies to everyone there. That wasn't fair to you, but we just wanted to get through that material. You know, we're trying to get through a whole year's worth of material in 3 hours. It's just tough to do. What I'm going to do is I'm happy to go through and do 1 or 2 more examples here. If you want to start doing the quiz, I'm going to open up these quizzes after 2 more examples. And if you want help, I'll give you help with those. If you have questions about questions that we've already covered, but you want me to do them with more explanation or slower or a little bit like I don't quite get these yet, here's what I'm here to do is just to help you guys out. So again, if you want, please type in the chat and ask me to do a certain question again, and I'll absolutely do that. I just want to finish doing these questions, number 11. And these ones are ones that we've done. I just wanted to just make sure that I complete these. Here we've got a fraction divided by a fraction, but this is a mixed one. We want to turn this in improper. Again, seems so long since we've done that. So I'm just going to rewrite this. This is 4 times 1 plus 1. 4 times, it's going to be a negative, so I'm just going to put that negative in there somewhere. 4 times 1 is 4, plus 1 is 5. Okay, this looks like much more doable. So remember, when we've got a fraction divided by a fraction, we're going to flip this side, and we're going to flip this whole fraction. So the first one stays the same. Going to flip that divide into a times, and we're going to flip this fraction top to bottom, bottom to top. I'm going to grab my special crayon because I can see that there's some cancellations I can make. I could figure this out here. I'm going to do it one way, and then I'm going to do it another way. I'm going to multiply. I've got a negative times a negative, which gives me a positive. So my answer is going to be positive. I'm just going to put a little positive there, but just to remind me that the answer is positive. So when I'm multiplying fractions, I multiply the tops to give me the tops, and I multiply the bottoms to give me the bottoms. So it's 5 times 4, which is 20. On the bottom, it's 2 times 5, which is 10. And I could divide both of those by 10, divide this by 10, and it gives me positive 2 over 1 or 2. The other way that I could do it is if I stop at this point, say, okay, I've got a negative and a negative, so it gives me a positive. That's fine. If I can divide the top and the bottom, one of the numbers from the top and one of the numbers by the bottom, as long as I do it to both top and bottom, then it works. So I'm going to divide the top by 5. I'm going to divide the bottom by 5. I'm going to divide the top by 2, which gives me 2, and the bottom by 2, which gives me 1. So now when I'm multiplying, negative times negative is going to be a positive. 1 times 2 is 2 on the top. 1 times 1 is 1 on the bottom, which is essentially 2. Same thing, same answer. Just this way is faster. That's all there is to it, to me anyways. If you prefer this way, fantastic. And also 20 out of 10 is the correct answer. It's just not simplified. And so you might lose a half a point from some teachers. All right, this one's great because it's already in proper or improper fractions. So let's do that. Keep the first one the same. Flip the divide and make it into a multiply. And we're going to flip this one. Don't forget about the negative sign in there. It's going to be 27 over 14. Okay, I'm trying to tell you how cool it is to be able to cancel top and bottom. So I'm going to do that with this one because this one becomes way less cumbersome. Can I divide the top and the bottom, either of these tops and either of these bottoms by the same number? Well, what if I divide this by 7 and this by 7? 7 divided by 7 is 1. 14 divided by 7 is 2. Can I do any more? Well, I bet you I can divide these ones by 3. So if I divide this by 3 and this by 3, that gives me 9. And I think that's as much as I can cancel. Now it's 1 times 9, we're doing negative 9 on the top. And on the bottom, it's 1 times 2. And it's a way easier problem than having 7 times 27 over, 42. This is a way easier way of doing it. All right, 25 minutes later, we finally made it to the end. I'm going to load up the quiz. If anyone has any questions, please, at this point, I would love for you to chat away in the chat box and tell me what you want, or unmute yourself and ask me away. Ask away your questions.